Hello and welcome to this video on the series on carboxyl derivatives. My name is Ochem, and in this video we'll be predicting the products when an acyl halide is used in a reaction. In a previous video, the synthesis of acyl halides from carboxylic acids was discussed. This video will focus on the kinds of reactions that acyl halides can undergo, since acyl halides are the most reactive of the carboxyl derivatives, which was also described in an earlier video. Acyl halides provide an excellent electrophilic carbon and can be the site of attack for a nucleophile to generate a less reactive carboxyl derivative. In general, identifying what the nucleophile is when you have an acyl halide will tell you the kind of product you'll form, since the halide will always function as a leaving group. One specific reaction I want to mention is when an acyl chloride is combined with Gilman's reagent, which is an organometallic reagent. Organometallic reagents are interesting in that the alkyl group functions as a nucleophile. In my example, Gilman's reagent in question is lithium diethyl cuprate, where one of the carbons attached to the copper in Gilman's reagent will attack the carbonyl carbon, kicking off the chloride as a leaving group and to create a new functional group, a ketone. The reaction mechanism for acyl chlorides in Gilman reagent is beyond the scope of this lesson and is not well understood. The overall mechanism is the same as generic nucleophilic substitution reactions. Nucleophilic attack of the electrophilic carbonyl carbon, loss of the halide, and the creation of a new functional group which contains a carbonyl. Let's see this in the applied question. You're asked to predict the product of the following acyl halide substitution reactions. In A, butanoyl chloride is reacted with ethylamine. Remember, the site of nucleophilic attack will be the carbonyl carbon, so the next thing to identify is the nucleophile itself. The lone pairs on the nitrogen would be a great source of electrons, so nucleophilic attack of the nitrogen onto the carbonyl carbon will cause the electrons in the double bond to migrate up to the carbonyl oxygen to create this intermediate. Next, we need to look for the leaving group. Since halides and acyl halides are a great leaving group, the chlorine is kicked off, we have reformation of the double bond to create the product N-ethylbutanamide. Notice that we've swapped out the acyl chloride for an amide. The second reaction is ethanoyl chloride with lithium dimethyl cuprate, which is a Gilman reagent. Recall that one of the alkyl groups will function as a nucleophile, so the methyl group will be the nucleophile that attacks the carbonyl carbon, and the chloride will leave to form our product, acetone. In this reaction, we're swapping out an acyl chloride for a ketone. Acyl halides are ripe for nucleophilic attack, and as long as you can recognize what the nucleophile will be, predicting the products of these reactions are straightforward. Make sure you follow up with some practice.